To wrap up Chapter 1, we'll talk about radical equations. So let's talk about the core approach. Remember how we solved the equation x minus 3 quantity squared equals 2 by taking the square root of both sides. This action effectively freed x, which was trapped under the power of 2. We're essentially going to reverse this process. Suppose instead that we had the equation the square root of x minus 2 was equal to 2. Now x is trapped underneath the radical, and I can negate this by taking the square of both sides. So take the square root of x minus 2 equals to 2, square both sides, and then what we'll get is x minus 2 equals to 4, and we could solve this to get the solution of x equals to 6. So at their core, radical expressions essentially are solved by this type of maneuver. You are going to take some kind of power of both sides that will negate the radical that we see. If I see a square root on one side or the other, I will square both sides. If I saw a cube root on one side or the other, I would cube both sides, and so on. But there's something I need to be careful about. Every solution that I get needs to be checked, because I can't plug in anything I want into a square root. So let's make sure that this value of x equals to 6 makes sense. Plugging it into our original equation gets me the square root of 6 minus 2, which is the square root of 4, which is 2, and that agrees with the right-hand side. So this is kind of similar to when we checked restricted values of rational equations. We needed to double check that our solution was valid and made sense. We'll see why this matters in a later slide. One very fair question is, why do I only get one solution? Because we were getting two solutions when I was taking the square root of both sides. So what's going on here? Why are we only getting one solution for a radical equation? The difference is this. Even powers and even roots aren't exactly opposites of each other. I can square the number negative 2 and only get positive 4 as an answer. However, if I'm solving the equation a squared equals to 4, I can plug in two distinct values for a, positive 2 and negative 2. Both, when I square them, are going to output an answer of 4. So that's why this is a little bit different. Squaring a number only is going to give me one possible outcome, but taking the square root of a number in the context of an equation does have two possible outcomes. So that's why we say that even powers and even roots aren't polar opposites of each other. For our next example, let's solve the equation the square root of x plus 10 equals to x minus 1. This example is going to show why some solutions that we collect may not actually work with the original equation. But let's get back to the work at hand. First, let's shift things around. I want only the radical on the left-hand side of the equation, and I want everything else on the right-hand side of the equation. We'll start by subtracting a 10 from both sides. This will give me the square root of x plus 10 equals x minus 11. Now that I have the radical on one side, I can square both sides like I did in the previous slide. This is going to give me x plus 10 is equal to x squared minus 22x plus 121, which is the result of the right-hand side when I FOIL. Now that all of my radical terms are gone, I have a quadratic equation. So let me put it into standard form and simplify. What I get is x squared minus 23x plus 120 is equal to 0. It turns out this factors. It factors as x minus 15 times x minus 8. Because the coefficients are larger, it might take a little bit more guesswork, but the number 120 does factor as negative 15 and negative 8. And when I add those numbers together, I get negative 23 as a result. And using the zero product property, I get the solutions of x equals to 15 and x equals to 8. But we need to check that both of these solutions are valid. I do so by plugging them into the original equation and seeing if I get a true statement. When I plug in 15 for x, I see that both the left and the right-hand side of the original equation both come to 14, so I have a true statement. The same cannot be said for x equals to 8. When I plug in 8 for x in the original equation, my left-hand side reduces to positive 13, and my right-hand side reduces to positive 7. Clearly these are not equal, so plugging x equals to 8 gives me a false statement. This doesn't mean that we made an error in our process. It just means that when I start squaring both sides and introducing quadratic terms, I might just have a little bit of mud in the water, so to speak. It just means that certain false solutions do arise, even though they aren't actually solutions to the original equation. So the process wasn't wrong, it's just that part of the process involves checking our answers. X equals to 15 is a valid solution, so we're going to record that. However, we refer to x equals to 8 as an extraneous solution. Essentially, if you're casting a fish net, you might pick up something that isn't a fish. It doesn't mean that there's anything wrong with the net, it just means that you picked up more than you needed to, and you need to throw the things back that you didn't intend to catch. For our last example, let's consider something a little bit more challenging. I have the square root of x plus 1 plus the square root of x minus 2 equals to 1. If this was a rational equation, I could combine a constant 1 with a fraction, but you can't really do that when you have radicals. The first thing I'm going to do is at least move things around so that I have one radical per side. I'm going to write this as the square root of x plus 1 times 1 minus the square root of x minus 2. It's a good posture to have one radical per side of the equation. The next thing I'm going to do is square both sides, and that just means that I'm going to have to FOIL out my right-hand side. The details for all this are explained in the notes very thoroughly, but what we're going to get after we FOIL the right-hand side and square the left-hand side is x plus 1 is equal to 1 minus 2 square roots of x minus 2 plus x minus 2. Note that the term x minus 2 came from the square root of x minus 2 squared. Like I said, this is what you get when you FOIL out the right-hand side. But what I'm going to do now is solve for the radical term. I'm going to get the radical term on its own side of the equation and move all other terms to the other side. This turns into 2 times the square root of x minus 2 equals to negative 2. And when I divide both sides by 2, I get the square root of x minus 2 is equal to negative 1. If my right-hand side was a positive number, then I would have squared both sides and solved it like normal. But my right-hand side is a negative number. This means that I actually have no real solutions. That means that the problem is done. Whenever I have an even root of stuff equals to a negative number, I can automatically stop and say I have no real solutions. But again, if the right-hand side was a positive one, I would have just squared both sides and solved for x like I did in the previous examples. I would check for extraneous solutions and then record my results. Well, thank you very much. This will be the conclusion of all Chapter 1 videos, and we'll see you around for Chapter 2.